Alright guys, so we are going to be talking about Unit 3.1. So we started a new unit. This is going to be our first lesson, and you notice we're going to be talking about graphing inequalities. Our learning target, like we just discussed, is I can graph inequalities on a number line. So what is an inequality? An inequality is a relationship between two values or expressions that's not equal. Okay, so it's just a relationship between two values or expressions that are not equal. So some inequality symbols. They're read from left to right. And if you happen to see this notation right here, all that means is they're not equal. It's just an equal sign with a line through it. It just means they're not equal. You have your greater than sign, and you have your less than sign. You also have a greater than or equal to, or a less than or equal to. You notice the difference. Greater than or equal to and less than or equal to, they have a line below the inequality sign. All right, so if you see that line, you're going to know that it's or equal to. And I'll scroll back just so you can see the difference. All right, so you have greater than and less than, no line underneath. Greater than or equal to, less than or equal to, you have a line underneath your inequality sign. That's all there is to it. So solutions of an inequality, they're any number that make the inequality true, and we will talk about that more in our examples. Okay, but you can take any of those solutions, and or anything that is shaded on that number line, substitute it back into your normal inequality, and it will make that inequality true. Okay, and they'll have sets of solutions. Notice I didn't say there was one number that you would take and substitute back in. Any of those numbers that are shaded, you will be able to take that and put it back in, and that inequality will be true. Okay, so this is just your standard number line. All right, so when we say number line, this is all we're talking about. All right. And then notations. So when you graph and you're graphing an inequality, you're either going to have an open circle or a closed circle. And that's what these are talking about here. So if I have greater than or less than, it's an open dot. So when we graph on that number line, it will be an open circle. And if I have greater than or equal to or less than or equal to, it's going to be a closed circle. All right, so you'll understand that more when we talk about our examples, but that's all there is to it. So if it's greater than or less than, it's an open circle. Greater than or equal to or less than or equal to, it is a closed circle. So anytime you see this line underneath, it's the easy way to remember it, you know it's going to be a closed circle. All right, guys, so our first example when it comes to graphing inequalities, we are given an inequality and told to graph it on a number line. When we're starting this, the way I like to do this is to look and see, am I going to have an open circle or a closed circle? And we know that comes directly from our inequality sign. And we know if it does not have a or equal to or have that line underneath the inequality sign, it's going to be an open circle. And for this instance, we have x is less than 3. Our variable is isolated, so we know our open circle is going to go at 3. Let me change that. Our open circle will go here at 3. And with our variable being on the left-hand side, it's we can just go ahead and we can shade in the direction of that inequality sign. And all of our solutions here, it will keep going to even numbers that are not on our number line. And we can check our work. We can check to see. We can pick any solution that has been shaded. I can pick any of these numbers right here. For this instance, we'll take -2. Is -2, we'll substitute it in for our variable, is -2 less than 3? Well, absolutely. It's a negative number, and we have a positive number. We know negative numbers are less than positive numbers, So negative 2 is less than 3, and we know we are good to go with that problem right there. Let's look at our next example. You have x is greater than or equal to negative 2. And notice our example, it's still example 1 because we're dealing with the same kind of problems. So this is just our second example in example 1. We'll look at our inequality sign. Give you a second to think about it here, but are we going to have an open circle or a closed circle? And we know, based upon our rules that we have discussed, it's going to be a closed circle. So, or equal to, so it will be a closed circle. Variable's on the left-hand side. It's isolated. It's by itself. So we can go to negative 2. We can go to negative 2. It's a closed circle because it's greater than or equal to. And we can just follow the direction of our inequality sign. You have to be careful when doing that. That variable has to be on the left-hand side if that's the way you're going to think about it, which is the way that I do, and that's the way we're teaching you to do it. Get your variable on the left-hand side, which it is. It's right here. We can just follow that direction of our inequality sign. And we'll look at examples here shortly where you're going to have to flip some things around, and we will discuss that. But we're going to check here. We'll pick any of these solutions. Let's just pick 4. Is 4 greater than or equal to negative 2? Well, it's a positive number. It's bigger than a negative number, so we know that one is correct. All right, and our last example here of graphing inequalities is this right here. And what I just discussed, my variable is not on my left-hand side. Notice how it is on our right-hand side. What I need to do, the easiest way to do these, is I need to move it to the left-hand side. But when I do that, I have to flip my inequality sign. So I'm going to move my variable to the left-hand side, but I have to flip it. If I don't flip it, I will be incorrect. I have to flip it. I kept my or equal to, right? I kept the line underneath it, and the negative 1 will go on the right-hand side, and now I can graph it very easily. Think about it. Do you have an open circle or a closed circle here? The rules we've discussed, we know it's going to be closed. We know it's going to be at negative 1. We know it will be at negative 1 here. Our shading will be to the right, because what that's saying is every number that I have shaded is going to be bigger, is going to be greater than or equal to negative 1. And just to kind of drive something home here with our inequality sign, how it's or equal to, how it's greater than or equal to. Let's choose negative 1. Is negative 1 greater than or equal to negative 1? Well, absolutely, it's equal to, right? It's the same exact number. So we know that one is correct. I have my closed circle. I can use that to check my solution. All right, so we just worked on graphing an inequality on a number line. Now we're going to be given a number line, and they want us to write an inequality. So these are very simple. The easiest way to do these are just go ahead and put your variable and write it on the left-hand side. And now we're looking at our circle. We're looking to see, is it going to be open or closed? And we see here for this one how it's open, right? It's an open circle, so we know it's just going to be greater than or less than. And with my variable being on the left-hand side, I can just write my inequality sign in the direction of the shading. So for this one, we know it's going to be less than. So x is less than, and we're just going to look at where the open circle is, and it's at 5, so x is less than 5. And we can check, just like most things in algebra, we can check our work. So let's just pick a number off of the number line that is shaded. And we'll just use 0 for example. Is 0 less than 5? Yes, we know that we have written this inequality correctly. All right, so very simple. Just go ahead and write your variable on the left-hand side, and it makes everything very easy from there. So let's look at another example. Go ahead and write my variable. We'll use x. Looking to see if we have an open or a closed circle, and we notice that this one is closed, so we know it's either going to be greater than or equal to or less than or equal to. And look at our shading. We know that it's shaded to the right, so it's going to be greater than or equal to, and the closed circle is at 0, so x is greater than or equal to 0. All right, and that's all there is to it.